All right, grade 11s. This one is an identity lesson. We are going to prove identities. So it involves us taking perhaps the left hand side and simplifying it until it looks like the right hand side. Or at times we may take the right hand side and make it look like the left hand side. So I am going to teach you those identities in parts. So today I'm interested in those identities where you use fractions. Normally there will be fractions on one side where you have to take two or three fractions and put them under one denominator and then solve. That is the strategy we are going to mainly use today. So it's also important for you to be able to identify when that skill is needed. When is it that you're expected to take two fractions under one denominator, and when is it that you're expected to split them? So before I go deep into that, please notice we are expected to remember identities such as this one that we learned already. We know that tan theta is always going to be seen as sine theta over cos theta. This is the identity we will use to prove all the other ones that we have, and also these two, like this one where we say sine squared theta plus cos squared theta is equal to 1. We know this identity very well. On a lesson that we had before, I once said if you would like to just say you have sine squared theta and you want to change it and express it in terms of cosine, you can write it actually as 1 minus cos squared theta. You can see that that is possible if you make sine squared theta subject. So again, at times you may want this and at times you may need brackets. Notice how this side can also be seen as a difference of two squares, and you can write it as 1 minus cos theta multiplied by 1 plus cos theta, like this. So depending on the situation you find yourself in, you can express sine squared theta as that, or you can express these brackets as that, which will then be equal to sine squared theta. The same is true for cos squared theta, okay? So you can really express it as well as 1 minus sine squared theta, of which you can notice how this is a difference of two squares, and also write it as 1 minus sine theta, 1 plus sine theta. So you should be able to identify when this thing arises. So it all comes to perfection after you practice. So let's just do that. Let's start with the two that are on the board already. Maybe if we have 5 or so examples in this video, it should help a bit. So before I erase that, let me just go straight to that one. We said we're going to do two fractions today. And you can see on the left hand side of this identity, there are two fractions and it's reducing to one fraction. You have to prove that the sum of these two fractions actually is equal to that. So the strategy we use here is we just take this under one denominator. As you can see, these two are actually not the same. There is nothing common about them. So you take them as they are. What I mean is you just multiply the two to get the lowest common denominator. So it will be this one this time around. And I say to you, if ever you take the denominators like this, just multiply them as they are, what you do on the numerator is more like this one should multiply that and that should multiply that. It's like you're cross multiplying the fraction. But it's just the way we see it when we take these as they are here. So let's just go. This one will multiply 1 plus cos theta, and then sine theta itself will multiply 1 minus cos theta. Well, for marks you have to mention that you are simplifying the left hand side. In fact, copy it again and then carry on. I am more concerned about space today. Okay, so remember we want to get to this point. So let's simplify it until we get there. We can see we can get rid of the brackets on top. So I'm going to call that sine theta, and that will be plus sine theta cos theta, like this. Then if I multiply there as well, that you can easily see what I'm doing. Sine theta cos theta. I'm getting rid of the brackets. Now on the denominator now, this is what I want you to see. We would like to have only sine theta eventually, and it doesn't look like we have sine theta now. But if you remember what I just mentioned a few minutes ago, this is actually a difference of two squares, which we can write if we FOIL it to become 1 minus cos squared theta. You know the middle terms will cancel, so this will be, these brackets are equal to that. And again, this, from what we know, it will be equal to sine squared theta. So we are going to do that on the next step. Notice how things cancel here as well. So this term here and that term are like terms and they are cancelling. And these are like terms, so we are actually going to get 2 sine theta over there. And like I said, this right here is equal to sine squared theta from that identity, this one. So as you can see, sine theta, one of these here will cancel with one of that, and you can see how we will have 2 on the numerator and sine theta on the denominator, which happens to be equal to the right hand side. So that's what you do really when you're proving identities. So this time around I'm teaching you where you take 2 fractions or 3 and simplify. So let's quickly see a few more examples now that you know what you're expected to do. Here you can tell you have to simplify these fractions, so I'm going to just go and do so. You can tell that here, the lowest common multiple, you can get it by saying this. Since we took them as they are, this 1 should multiply that. So it's as good as you're saying 1. It's weird to write it like this, but let me just do it. And then plus that 1 multiplying with that 1 plus sine x. Really, I didn't have to. I could just write it as it is without brackets, but for you to see what's going on. Alright, so now I'm going to expand. As you can see, this will still be 1 minus sine x plus 1 plus sine x. So 1 plus 1 is going to be equal to 2 over there. Maybe I should put this step where I just do this, because some of you may get lost in the process. And this here is a difference of 2 squares, which is 1 minus sine squared x as well. So now notice how that and that will cancel. And luckily we remember what 1 plus 1 is, right? And this will be cos squared x from what I told you on that identity. So this is again what to do over there. So copy that quickly. Let's go to number 3 and see what is expected of us. So I'm going to put number 3 quickly here. Remember, the question is you have to show that the right hand side is equal to the left hand side, and don't forget to actually state that it is equal to the right hand side. It's very important that you do that. Okay, here is another identity that we can prove. If you want to try it on your own first, go ahead. I don't have a problem with that. And then let us see what we can do. All right. Right, so you have cos x over 1 plus sine x, then plus tan x. You should show how this is equal to 1 over cos x. Let me give you a minute to do that while I copy number 4 down here. So I'm going to let you answer that. In the meantime, I'll be putting number 4 somewhere down here, and let's see if you will finish it fast. Okay, so I'm sure you went somewhere, you got to a certain place here trying to prove this. Maybe the drag was you didn't see your fractions easily. Well, it was actually there. You just needed to first of all change, let me mention how I'm starting with the left hand side. You needed to mention how tan x is actually equal to sine x over cos x. It's very important to remember this identity for tan x, okay? So that's what you expected to do, and once it is like this, then you can see the same as the previous examples we had, so we can easily get it going. So I'm going to put cos x down here, and I think you're noticing I just multiply these two. I didn't do anything else, so because I did that, you can just cross multiply. So cos times cos, it will be cos squared x, and sine x should multiply 1 plus sine x, like this. Okay? Because we took the denominator, we took both of them as they are and multiplied them. Okay? Let's not lose sight of where we want to go. This cos x is actually needed, so we are not going to disturb it at all, but the numerator we can, because we don't seem to want anything that's there. So this is going to be sine x, and sine x times sine x will be sine squared x. I'm not going to let the cos x go away at all. I need it right there. Right. This is a very important step, because now it's teaching you how you should notice, please, cos squared x plus sine squared x. I think you remember that that is an identity I mentioned is equal to 1. So on the numerator we'll have 1 plus sine x, and on the denominator we still have cos x over 1 plus, multiplied by 1 plus sine x. Notice we couldn't just cancel cos x with one of the cos x and sine x like that here, because of this plus sign on the numerator. So in this situation, you can only cancel these things with plus or minus if they are in brackets. It makes it one term inside the brackets over there. That is, if you can also do that, that's the only way you can cancel the whole thing like that. So it means this will be 1 over cos x, which is like the right hand side, isn't it? So I'm sure you got that one right. Okay, for this one, really you could start with any side and you were going to get there anyway if you started with the left hand side or the right hand side, but for the purposes of this lesson I will start with the right hand side, because that's where we can form two fractions, and then on those two fractions we can really carry on. So firstly, I want you to see how tan x is sine x over cos x, and let me just do this. Tan x over 1 is equal to sine x over cos x. Please people, if I invert and say 1 over tan x, so it means, if you're looking at this properly, you should now see how that is cos x over sine x. So it's what we have in this situation. We're going to change this to that, and this here, we are going to change it to that. And that is how we are going to do those fractions right there. So now that you've got the point, let's substitute. This one, we said, so I'm going to start with the right hand side this time. So the right hand side, from what we said, you can copy it first, and after you copy it, then you change it to cos x over sine x like we agreed, and that one is already sine x over cos x. So that is what we have. Taking it under one denominator, so if ever you multiply these two, if you take it as it is like this, then you don't stress about the numerator, you just multiply. So as you can see, it will be cos squared x, and from what I'm noticing, it will be minus sine squared x. Now the drag is, we seem to have the denominator here already, so we seem to be fine on the denominator. But when it comes to the numerator, we really don't want to have cos squared x. So if you remember from the identity I taught you at the beginning, cos squared x, this one right here, can be written as 1 minus sine squared x. And then, of course, that one is already there, like this. And if you're looking, then that's how you will notice that we have like terms here. These two are like terms. So it will be 1 minus 2 sine squared x over sine x cos x like this, which happens to be equal to the left-hand side. So make sure that you are following and make sure that you're understanding what's going on over there. Okay, so I will not leave the lesson before I just tease your brain a bit. I want you to be ready for the identities that are a bit tough to solve. Okay, so I am going to put this question 5, and I will challenge you to do it first before you look at how I will solve it. And I would like to see if you can solve it from both sides, the left hand side to the right hand side, and also from the other side. So this one, it doesn't look like it's much of fractions at all. We don't seem to have any fraction going on. So look at what we've got here. If I have 5 tan x plus 2 over cos squared x is equal to 2 tan x plus 1, and then we have tan x plus 2 like that. And then we really want to prove that. Well, people notice that it is not exactly this. If you try to handle this side, since you can change that to sine over cos, well, you can go ahead, but forming tan x's from these ones might be a bit difficult. So I want you to try both sides and then see what's what. So we are going to handle this type of identities in our next lesson. So let's just have a feel of what to do here. So what I'm going to do, however, for this one is I'm going to take the brackets and handle the brackets and see if I can come to this side. So I am actually going to use the right hand side and simplify it. Let's see if we can get to the final solution. I am getting rid of the brackets. I hope you can see that. And then this, notice it's 4 tan x, and then there is 1 tan x here. So I think I should just write it as 5 tan x, and 1 times 1 is simply going to be 2. So there is a bit of hope, a ray of hope showing. The only thing we seem to have, you know, that's what we seem to have. So what it means is that I can leave that one alone, but these two have to somehow become equal to that. So I have to really change this to sine squared over cos squared and see what happens. So I'm going to bring this one, notice I'm going to do this over cos squared x, and then take that 2 here, say over 1, plus the 5 tan x, which is already here. So I am going to just take these 2 here under one denominator. So the denominator that we've got is cos squared x. If I multiply these 2, I'll get this. So I'm going to also do what I mentioned before. I can say, well, this will be 2 sine squared x, and that will be 2 cos squared x plus 5 tan x. We're just carrying on, aren't we? I hope you can see a future from here. Notice on this term here, I can take 2 out on the numerator. Then we'll have sine squared x plus cos squared x left, and cos squared x like this. I got what I want, so I am keeping it safe with me right there. Now you have to remember something. This whole thing here, from what we said, it is actually equal to 1. So as we are seeing what's happening here, it will be 2 times 1, which will simply be 2 over cos squared x right here, and then plus 5 tan x. So you can see that is exactly what is on the left hand side of this. So these are the identities we'll be working out. So you will do your own exercises, then ask a few questions before we carry on. Okay, good. That's all for this video.